So today, as the title suggests, we are going to be talking about the structure of the occipital, parietal, and temporal lobes. So let's just jump right into it. We'll start with the occipital lobe, and its function is pretty straightforward. It's the primary visual area of the brain, and what it does is receives projections from the retina via the thalamus. So what's really happening at a molecular level is that there are separate groups of neurons that specifically encode different visual information, such as color, orientation, and motion. So there are two important pathways of information in the occipital lobe from which this newly processed information can be projected to the parietal lobe via the dorsal stream and to the temporal lobe via the ventral stream. As indicated in the diagram, two separate questions are answered from the two separate pathways. The dorsal stream answers the question, where is the object? Whereas the ventral stream answers the question, what is the object? Because the occipital lobe plays such an integral role in sending vital visual information to the parietal and temporal lobes, would damage to this area in the progression of Alzheimer's dementia subsequently cause miscommunication to the ventral stream and the dorsal stream. Furthermore, how would this miscommunication affect the function of the parietal and temporal lobes? I'll attempt to answer these questions later, but for now let's move on to the structure of the parietal lobe. When I started researching the parietal lobe, I learned that it plays an important role in integrating information from different senses to build a coherent view of the world and view of your surroundings. And I know that for Alzheimer's patients this is very difficult, and it just reminded me of this video that I first watched a couple years ago, but I still watch it today because I find it very eye-opening. And I'm just going to take some time now to share this video with you. It's just a couple minutes long, but I think it'll be a good way to introduce the parietal lobe, and it will help you draw connections to Alzheimer's disease before we get into some of the molecular structure.
Labor Shack. The experiment helps families and caregivers actually experience what it's like to have Alzheimer's.
I understand it's a pretty rough experience.
It needs to be experienced. If it'll help me to understand, I would love to.
I agreed to undergo the experiment with him.
Could you have a seat, please?
Our journey into another world begins here, in this bedroom, where Blaine and I are suited up with some deceptively harmless-looking devices. Goggles simulating macular degeneration, glaucoma, and cataracts, conditions that older people with Alzheimer's often have. Likewise, latex gloves are placed on our hands, and our fingers are taped to make our hands feel arthritic, clumsy, hard to bend.
Remove your shoes.
A substance is placed inside our shoes to make it harder for us to walk.
Ooh, that is uncomfortable.
And on our heads they place earphones, which emit an incessant jabbering, a clamor of noise that some Alzheimer's patients say is constant.
Individuals with dementia say, we're hearing all this stuff and they can't turn it off.
Then we're each given 5 tasks to perform, and only 12 minutes to accomplish them.
I'd like you to find the tie and put it on.
I can't hear you.
Blaine has a hard time concentrating from the start.
Your time begins now.
As he enters, Blaine is immediately disoriented. He staggers, reminding us of the way his mother looked on our tapes. Blaine tries to accomplish his first task, clearing the dishes off the table. But when he goes to put them away, he can't find the kitchen. So he gives up.
Well, I don't know where to put it.
Blaine finally finds the kitchen, but he can't remember why he's there. And again, the similarities to his mother were astounding.
She would open cabinets and then she would shut them. Mother, what are you doing? Nothing?
But Blaine is doing a lot better than I am.
As you can tell by the video, it's very difficult for a patient with Alzheimer's disease to develop awareness of their surroundings. So this makes me wonder if the progression of Alzheimer's has an impact on the function of the parietal lobe. Research has shown that the parietal lobe synthesizes messages from the ventral and dorsal pathways in order to allow for coordination of movements in response to the objects and a person's surroundings. I also learned while doing research that if there was damage done to the parietal lobe, it would cause an inability to locate or recognize different objects or events or even parts of the body. It also causes difficulty in discriminating between different sensory information coming from the dorsal and ventral pathways. It causes disorientation and a lack of coordination. And what's interesting is that in patients with Alzheimer's disease, this is a lot of the difficulty that they face. So it makes me wonder what connection there is between the progression of Alzheimer's and the degradation of the parietal lobe. Alright, so for the last segment of this video, I'm going to be talking about the temporal lobe, which will actually give us a really nice segue into the next video I'm going to be filming, but for now, let's focus on its structure. So the temporal lobes are located inferior to the frontal lobes and the parietal lobes, and it's pretty much centered between the two lobes. It contains several significant substructures, some of which we'll be exploring more in depth, but some of these include the amygdala, the primary auditory cortex, the superior temporal gyrus, Wernicke's area, the middle temporal gyrus, inferior temporal gyrus, and forciform gyrus. Alright, so we're in the last leg of the video, and thank you if you stuck around with me this long. So I downloaded this cool app and I thought I would show you this. Hopefully it's an entertaining end to the video. And what I'm going to do now is I'm just going to remove some layers from the skull and remove another layer, and I can take a cross section of the brain. I can add pins, and right here is the temporal lobe, and I'll talk about the functions of the substructures and also the lobes. So they are perception, face recognition, object recognition, memory acquisition, and the understanding of language and emotional reactions. Alright, so before we go, I just wanted to point out the fact that a lot of the functions of the substructures and the lobes are very closely related to the main symptoms of Alzheimer's. So this will definitely be a talking point in our next video. Just want to say thank you for joining me, and the next video will be posted very shortly.